This is Math 2 extra practice worksheet from Unit 12 homework questions. So this is the worksheet that you should have out. And I'm going to go over numbers 2, 5, and 8, talk about 7 and 9, and do some from the back side as well. Okay, number 2, what is the measure of angle D? All right, so they gave us a lot of information here, like some of it is extra information. So let's figure out what I need. If I'm looking for this angle, that's not a central angle, it's an inscribed angle, and it intercepts this arc, and they're not equal, but the angle is half the measure of the arc, so we're going to cut 64 in half, and we get 32 degrees for angle D. Okay, number 5, what is the measure of CB, arc CB? So this one gives us extra information as well. We may need it, we may not, we'll figure it out. Okay, I'm looking for arc CB, which is not made by any kind of central angle or inscribed angle. It's not made by any of that. So I am going to use some of the extra information. Now, do you notice that arc CB and arc CD, they're a semicircle? Can you see that? This here's the diameter because the center is A, and line DB, chord DB, goes to the center, so it is a diameter. So half of a 360 is 180. So those two arcs there, those two color arcs add up to 180. And this color arc is made up with this angle here, this inscribed angle. And that's when you either cut in half or double. If you know the angle, you double. So double the 52 and you get 104. Arc CB, I'll call that an X for now. X plus 104 equals 180. You're going to subtract 104 from both sides. And X equals 76. So arc CB is 76 degrees. All right, number 8, what is the measure of arc DB? Now again, they gave us extra information. Is it extra or is it needed? Let's take a look. I'm looking for arc DB, which is here. And it's not made by a central angle or an inscribed angle, so I will need the extra information. And this little blue piece is kind of like this blue piece up here. It's not made by any special angles. Unlike this one up here, this one's not on a semicircle. Do you see that these two arcs made a semicircle? These two arcs do not make a semicircle, nor do those two arcs. But the three arcs together, that one that I have there, this one that I have here, which I do know we'll talk about in just a minute, and this green one down here that's 80, the three of those together make 360 because this time it's a complete circle. So X plus 80 plus whatever this big arc is here equals 360. Now take a look at the picture. If this is 75, what's the arc? Equal to 75, double 75, or 75 cut in half? I'm hoping you remember it's double, so this angle out here is 150, and I'm ready to make my equation. X plus 150 plus 80 equals 100, and I'm going to erase that because it's not 180, it is 360. X plus 150 plus 80 equals 360. I'll let you guys finish that one on your own. Once you find X, you're done. That's what you're looking for, arc BD. Okay, this one here, what is the measure of arc RCB? RCB. All right, in order to find the measure of the arc, you need to first know what X is. So find X, plug it in, and then add them up. So I'm going to at least make the equation right now. Arc RCB. We know that those added up together is going to be 7x plus 4x equals whatever it is I'm looking for. But I need to know X first in order to find that. So we need to work backwards or take a few steps back. How do we find X? We know all these little arcs together make a complete circle, so we know all of them together would make 360. All right, so find that first, add up all your x's, and that's not 36, that's 3x. Add up all your x's. That would be 18x equals 100, and I keep wanting to say 180, equals 360. Divide, once you find x, plug it in here. 7 times x plus 4 times x will equal the measure of that big arc there. All right, what is the measure of angle A? We did one of these in a previous lesson. A is half of this arc. How do I find the arc BC? 360 all the way around. 165 plus 95 plus x equals 360, and then cut it in half to find angle A. All right, I am going to move on. Number 10 we've talked about before. Both of these angles intercept the same arc. Do you see that little top there is also, both of those angles intercept that top arc. So look it up from the previous lessons and you'll figure it out. Are the dotted arcs congruent? Why or why not? Yes. And you can fill in the rest, because I'll explain it, you put it in your own words. Because in the picture, inside, these are vertical angles, and vertical angles are congruent. And we know that arcs are congruent to their corresponding angles, corresponding central angles. So whatever these two are, if this is x, this is x, that is x, that is x, they are congruent. So put that in your own words. Okay, I'm going to move on to 13. 12, talking about it. BC is a diameter, so we know that's a straight line. It's 180. What is the measure of arc DC? In order to know the arc DC, you need to know this angle, 9x minus 35. In order to know that angle, you need to know x. Since it is a straight line, 6x minus 10 plus 9x minus 35 equals 180. 6x minus 10 plus 9x minus 35 equals 180. You find x, and you don't have to plug it in everywhere. They want arc DC, so you're just, after you find x, you're going to plug it in there. No cutting in half, no doubling. It's going to equal the same as that central angle. Okay, 13. C is 40 degrees. What's the measure of arc CB? Okay, they put these little markings here for you. Even if they didn't, you should know it's an isosceles triangle, because AC is a radius and AB is a radius. They are congruent to each other, which makes these two angles in here congruent. So if angle C is 40 degrees, so is angle B. Is that enough to find the measure of arc CB? Well, let's see. Arc CB is intercepted by angle A. So if I can find angle A, I would then know arc CB, because this is a central angle, they would be equal to each other. All right, so can I find angle A? I'm hoping you're saying yes. I'm going to put a little X in here. Yes, because this is a triangle, and the sum of the interior angles equal 180. So x plus 40 equals 180. Subtract the 80, x equals 100. So if that angle there is 100, what is the measure of arc CB? Is it equal? Is it half? Is it double? It's equal, because central angles equal their corresponding intercepted arcs. Okay, moving on to 15, 16, 17. 15. If an inscribed angle in a circle intercepts a semicircle, what is true about the measure of the angle? We're going to use this, and we've talked about this already before. Okay. If an inscribed angle in a circle intercepts a semicircle. So here's the semicircle. Here is the inscribed angle, and that semicircle is the intercepted arc. What is true about the angle? Every single time, regardless of how it is drawn. So if I have this, and again I have a semicircle there and there, what's going to be true about that angle down at the bottom every single time? Well, if the arc is 180, and we know it's 180 because it's a semicircle, and inscribed angle is half, we know this is going to be 90 degrees. I'm just going to write 90 because that looked wonky. We know this is going to be a little better this time, 90 degrees. Okay? So anytime you have an inscribed angle in a circle and it intercepts a semicircle, that inscribed angles will always equal 90 degrees. You're going to write that out over here. The inscribed angle will always equal 90 degrees. Okay, if a tangent line and a chord are perpendicular, what is true about the chord? So we have a circle. Let's say I have a tangent line. And it's perpendicular. So there's my chord, there's my tangent line, and they're perpendicular to each other. Then if this is 90, you double the 90. So this arc over here is 180. What does that mean about this chord? What can you say about the chord if it cuts the circle in half? It is the diameter. So you can write that down. The chord is the diameter of the circle. If a chord is perpendicular to a tangent line, a tangent and a chord are perpendicular, what is true about the chord? The chord is a diameter. Okay. Again, you write that down here on your own. Refer to circle O where ABCD is inscribed in circle O. AC is a diameter and angle DAB is 122. Okay, AC is a diameter. It didn't mark it for us, but that's the diameter right there. And what else is given? Angle DAB is 122. This angle here is 122 degrees. Calculate the measure of angle BCD. BCD. Now, there's a rule, a property for these whenever you have a quadrilateral inside a circle about opposite angles. I've never shared that with you, so you don't know it, so I'm going to show you how it works. Okay, what do we know? We know this arc, and I'm going from D to B, crossing through C, or going around on the side of C. Do you see where that arc is intercepted by angle 122, and 122 is not a central angle, it's an inscribed angle. It's not a central, it's inscribed, which means you have to double the 122. 122 is 244. So this big blue arc is 244 degrees. 180 minus 244 is 116. So arc DB on this side, the smaller arc over here, is 116 degrees. Now finally we can find angle BCD. BCD is an inscribed angle, and the arc that it inscribes, that it intercepts, is 116 degrees. So we cut the 116 in half to find the angle, and we get 58. Now here's the quick rule that I've never shared with you. You don't need to have it memorized, but it's a pretty cool one. These opposite angles will always equal 180. Check it out. 122 plus 58 is indeed 180. And that works anytime you have a quadrilateral. Doesn't matter what it looks like. If you have a quadrilateral drawn inside a circle, opposite angles will equal 180. Okay, what is the measure of angle ADC and ABC? Now, this is going back to kind of what we've talked about previously. So let's see if I can change colors here. ADC, just use my pencil, ADC do you see that? Intercepts this big arc out here. Now it said earlier that ADC is a diameter, so what did I just draw over here? If I went from A all the way to C and AC is a diameter, then this pencil marking is a semicircle. And a semicircle is 180 and half of 180 is 90 degrees. All right. Oh, angle ADC equals 90 and 90 degrees. And what is ADC? No, ABC. ABC, same concept. Or use the rule I just showed you. These two angles should add up to 180. 90 plus what is 180? 90. So angle ABC is also 90. Or you can just think about it. That one there intercepts this semicircle over here. This semicircle is also 180 and half of 180 is 90. All in all, it works out either way. Okay, that is it for this set of homework questions.